So this chapter is applications of derivatives, like what can you do with them. These are all the things that we're going to do over the next like week or two. You can use derivatives to find the maximum and minimum values, which is what we're going to be focusing on for the next 2 days. You can find where it has an average rate of change. You know, we already know how to find the average rate of change, but you can find the point at which it actually reaches that average value as well. You can use it for determining the shape of a curve, you know, where it's going up and where it's going down and whatnot. And then the word problems that we'll look at are called optimization problems. You know, it's like where your goal is to figure out what's the maximum output possible or something like that. So, and that's obviously going to be connected to what we're learning today. So, that's Unit 5 in a nutshell. And let's jump into today's lesson. So, by the end of today's lesson, you should be able to identify the extrema and critical values of a function by looking at its graph. That's pretty simple stuff. A lot of vocabularies, sort of things. So. All right, so what are extrema? Extrema are the extreme values. So there's two types. There's the maxima and there's the minima. Okay, maxima is the highest value. Minima is the lowest value. You know what we should put on here is we should put highest y value, because when we're talking about those, we're talking about the height, the output variable. Okay. All right, so we're going to talk about two different kinds of these extrema. One is called global, also known as absolute, and the other one on the next slide is relative, also known as local. So we're going to talk about those two different types. So what is a global extrema? It's the highest or lowest y value of a function on some interval. So you guys could probably imagine, you could see that this here, if my pen is going to work. That's the global max, is what we would call that. Because at that point, there's nothing higher than that, right? The global minimum would be down here. There's no point that's lower than that. Yeah, what's that? Why would they call it global? So I guess a good, I don't know why they chose that vocabulary. They also put absolute. I mean, words are always arbitrary, right? So why did your parents name you Nikolai? Well, damn. I mean, there's all kinds of things that we could say there, but it makes sense to me because the word global means like complete, right? So in other words, that's the biggest and the lowest point on that graph, on that interval that you could possibly see. Now that's going to be contrasted with the next one where it's relative. The analogy I used last year when I was teaching this was with height. So, you know, it's possible for you to be the tallest person in your family, right? But does that mean you're the tallest person in the world? No. So if I were to say that you were the tallest person in the world, that would be like a global, like you're bigger than everybody else in the globe, right? But let's think of it, let's look at the next slide now where we look at the other type of extrema. There's the relative extrema. Now going back to our analogy, it's kind of like you're the tallest person in your family. In other words, people that are close to you, you're the biggest person there.
Relatives.
Like relatives, right? that was my reaction. All right. So now let me ask you a question. This guy here, would you agree that he's bigger than everybody in his family? Yeah. Absolutely, because he's the tallest guy in the world, right? So this is also a relative extrema. It's a relative max, right? Because it's the tallest, it's the highest point in that area. Now what I mean, it's taller than anything to the right or left. So if you were to go right or left, it's both of those points to the right and left would be less than that, right? And that's what we mean by relative. Just within that little close proximity is it the tallest or the highest. Yeah, what is the proximity? Well, anything to its immediate right or left.
Okay.
Yeah. So now here, anything to this guy's immediate right or left is going to be greater. So this is a relative min. Now, You guys may think, I thought they were globals. Now I'm confused. Those are globals, but globals are also, they can be relatives, okay? Now, the thing is, there's another relative max up here. You guys see it?
Yeah.
Right here. Don't you guys agree that that point is also higher than any point that it's to its immediate right and left? In other words, like the top of a hill. So that's another relative max. And this is a relative min. So you can have a bunch of these, whereas globals, you should only have one of those, I would think, right? You shouldn't be able to go beyond one. You're either the tallest or you're not.
Is there an example where it would be a relative match?
Mm-hmm. Yeah, we'll see a couple of those today.
Straight. Shouldn't like the relative tall max and relative small minimum be absolute since they're like
they are. Yeah, so this is a relative and it's global. So then going back to my example, if you're the tallest person in the world, you're also the tallest person in your family.
I thought global was absolute.
It is. So all of the ones on this slide, you can call them one of two things. Mathematicians use two words for them. They're either relative or local, right? Because they're close proximity. The ones on the last slide, you can either call them global or absolute, which means the complete total interval you're looking at.
Which one's more common to see on Calc?
Both. So I've seen a lot of, they're both pretty common. I would say relative is very useful. You're going to use relative a lot. Matter of fact, we use relatives to find globals. Kind of like if you told every family in the world, find your tallest person, and then you got all those people together, then you'd find the biggest person, right? It's kind of like that. You find all those relatives and you compare them afterwards. Yeah.
How are they different? How like global is different from local?
So in this case, they're not. These two, they are the same. The global is a relative. This, however, is a difference. This is a relative, but it's not a global because it's not the highest point on the graph. Does that make sense? It's just the highest in that area.
So in a relative graph, there would be a global and a relative?
Good question. We're going to learn a theorem today that says that guarantees there has to be a highest and a lowest point if certain criteria are met. Now, Zach asked, is there ever a case where it doesn't have one? Yes. And we'll talk about what criteria it is that specifies when there will be and when there won't be a relative or a global. So, but there you guys go. Those are relatives and globals. Now, as a caveat, I'm going to say you can technically, I guess, call this a relative. And it's higher than anything around it. The problem is that it's not two-sided, and that does kind of create some issues. So I've seen some mathematicians, they'll treat that like a relative, and others won't. So because there's some theorems about relative extrema where you can't use the endpoints, but in a sense it still kind of fits the criteria because it's still taller than the others. So some books think, you know what, just so I can say this works for all relative extrema, I'm not going to call that one because this rule won't work for that one. So just so you guys know, it's kind of arbitrary, but whether or not the endpoints count as relative extrema is kind of up in the air.
Do you know if there's any equations on that?
I wouldn't stress about it too much, and the only reason why I'm stressing about it is because as a teacher, when I look at all the resources, I was just kind of weirded out by the fact that different books are saying different things. So, yeah.
So, let's say that bottom, like the bottom point was on 0 for y, would that still be a minimum? Because it's the lowest point on y. Yeah. Like if this graph was.
So just shit the whole thing up? Yeah, still the lowest point, right?
So
Yeah.
So it's the lowest point.
Just the lowest. No, it does not have to be negative. All right, good question, guys. All right, let's keep going here. Yeah, that's interesting. For each diagram that follows, identify any extrema. So here we go. I'm going to go ahead and just include the endpoints for this. So this one would be a relative what? This would be a
and then min would be down there, and then that would be also a relative minimum. Oh wait, you're going down. That's relative max.
Wouldn't that be global?
Yeah, it's overall.
Oh, okay.
So could you call this a relative? Yes.
But you prefer global.
But yeah, you might, because I mean, it's kind of like you want to go with the one that's more encompassing, because if you say global, that kind of necessitates it being a relative. I mean, going back to the analogy again, if you're the tallest person in the world, you're definitely tallest in your family, right? So if you say global, that includes relative. So you don't really need to say it because it's redundant. So global is good enough. Over here?
Global minimum? I mean, no.
So you're telling me you're saying that all the globals will always be relative?
Yeah, I think that's fair to say, except, like I said, depending on what textbook you're looking at, endpoints excluded. Yeah.
What about that one right there? That's like connecting between the relative min and the global max. It's nothing.
It's nothing.
Nothing.
It was just a distractor.
And then you tease wax.
So,
Yeah, so that's the case where it's not a relative.
yeah, that point is neither, yeah. There's an infinite number of points up there. We're just looking at the few that are relative, extremas, and global. So, let's continue. Now, this is going to answer the questions that Zach and Thomas were asking about, like, will there always be one, and if not, when? So let's go ahead and label these. Let's call these 3 points. We're going to call them A, B, and C. So A, B, C. There we go. Determine if points A, B, and C are extrema. If so, determine what type of extrema they are. If they're not, explain why not. What do you guys think about A? Is that an extrema?
Yes.
Sure, we'll call it that, right? What kind would it be?
Relative
That would be
max.
relative max.
It'd be a relative max. And just remember, I prefer relative, but they do call them local sometimes. So, yep, relative and local.
Would I get wrong if I was?
I wouldn't mark you wrong, but if you're reading like a test question or something, like for the AP test, they say local, that it means relative. Part B,
Relative minimum. Global.
yeah, we'll actually say global.
Global. Global.
How about C?
Global.
Global man.
All right, how about here? A.
That would be none, right?
Neither. Now let's talk about this.
Let's talk.
It doesn't exist.
It's not there. There's nothing there. And the thing is, you guys, is that you can get closer and closer and closer to A, right? So there's always going to be another point that's higher than that. Does that make sense? But you'll never get to A. So that there's nothing there. Let's go ahead and take a look at part B, though. That's still a global min.
And then C is nothing.
And C is neither. So notice that this does not have a max. It's impossible. No matter how close you get to C, there's always going to be something else higher. And something else higher. And something else higher. You can never get it. There's always going to be something higher, so there is no max. Does that make sense?
Ah.
All right.
A is relative minimum.
Okay.
Yeah.
Oh, no, it's a max.
Relative maximum. My bad, Dad.
How about B?
That would be nothing.
It's neither or neither.
Neither. Or neither.
It's longer what?
Huh?
Oh my god. It's dusty?
It's fire.
How about C?
Global max.
Okay,
This one doesn't have a global minimum. Our rocks rock.
so here's what I'm trying to illustrate with this, you guys. If you have endpoints and there's no gaps, in other words, it's a continuous and closed interval, there has to be a global minimum and a global maximum. Somewhere you're going to find the highest and the lowest points. If the endpoints exist and there's no gaps. As soon as you start having gaps, you're not guaranteed to have a global min or max. Let me start with, go ahead.
What if it's like just a straight line or a tangent?
That works too. So that's a good question. So for a minute, suppose that this isn't here, the smiley face. Let's say I had this. What's your global max? That's true. What's your global max?
No, wait. The whole time
It's just the value.
Okay, now that's. I'm glad you asked this question. A global max is the highest what value? So what's the global max?
4.
What's the global min?
4.
So it exists. It's just weird.
What about if it's like a sign where it just keeps going up and down? It's the same exact.
Good question. Thanks for asking that too. So let's look at that. So Zach's asking about this. Let's say I had this. What's the global max?
5.
5.
5.
Yeah. Because it's the highest y value. Does it? So what's confusing is we're thinking, oh, it has to be 1 point, because that's what all the examples I've given you are. It's not. It's the highest y value. And even though it's repeated,
It's still
the highest y value is 5.
So would there be any relative or any local?
They're all relatives. Remember, because if it's global, it is relative. But is there just a relative on this one? No. Not if it keeps going.
Do we have any that are continuous and have the same pattern going downward?
Oh, that wouldn't be a function anymore. You're talking about this?
Yeah. What is that considered?
That fails the vertical line test, so that's not a function. Oh, that's an algebra 2 thing. You might not remember
Yeah.
that.
That's sine. What's algebra?
Arc.
The arc sine and arc cosine.
So.
We're
anyway.
calculus. Stop teaching us algebra too.
What about a linear line? Well, if you have a linear line, let me get his questions. These are cool. All right. So if I give it endpoints, remember it's got to be a continuous closed interval.
Yes.
Does it have a max and a min?
Yes.
It does. Now, if I say it goes on forever, does it have a global max and min?
No.
No. It doesn't. It never stops, right? That's right. So that is our. So those are all awesome questions, and now we've answered what Zach and Thomas were kind of hinting at earlier. Will there always be a global min and max? No. We're not talking about relatives right now, just globals. Will there always be a global min and max? No, but there will be if certain criteria are met, and I think that's on the next slide here. No? I guess I get to it next class. We'll get to it next class. It's called the extreme value theorem. But so long as it's closed and continuous, you will have a definite global min and max. Anyway, here's what I want you guys to do. I want you to tell me what x values are relative min, max, and global min and max.
like go up there, no?
Huh? So, Lucio, A, what's that? True. Art, what is B? Cool. Daniela, what is C? C?
It's neither, right? I just put both.
I put both.
It's neither.
Because
to the
Okay.
left is greater to the right. It's
So remember how a relative min or max has to be greater or less than every point to its immediate right or left. To the left, it is less than every point, but to the right, it's equal to. So that's not a relative min. Okay. That was a tricky one. Let's try Luke. What'd you get for D? That was same thing, right?
There's some weird tattoos,
Who?
Noises. What'd you get for E?
Good girl.
Paul. F. A lot of neithers up here.
It's got a lot of
Noah. G.
Did I? Or did I not?
Remix. Devin. H.
See, there is no global. I was right? There's no global. Because the lowest Mr. Bailey.
You're right. There's no global.
Oh, they're not global?
Nope. Because so let's see why there's no globals. The reason there's no globals
There's still higher points.
is because, as you can see, is this is the highest point. So
just never reach it.
it can never get there, so there's always something higher, right?
Alright.
Over here, this point is not lower than these points over here, right? So there are points that are less than that one, so we would look over here, but the problem is you can never get there, so it keeps getting lower and lower, even though it can't reach that point. There's always something less. So that, you're right, there are no globals on there. Yeah.
Off topic question, but is it not differential?
That's right. And that's not off topic. That's relevant.
Good job.
Is it differential, or are they indifferent?
They're non-differential. It's got to be continuous. Right? You can't smooth. All right, here we go. Find the value of the derivative at each relative extrema.
That's nuts.
So what's the derivative at this point?
0. I'm gonna go with 0.
It's 0 because derivative means slope, right?
Oh,
And my tangent line, the slope of my tangent line tells me the slope at that point. My tangent line is horizontal, therefore the slope is 0 there. Therefore, the derivative at that point would be 0.
Yes.
By the way, what is this point? It's a
relative max.
Oh.
Or a global max.
Or
No.
global.
Okay.
No, because that one just goes on infinitely. The one going down just goes on infinitely. There's no...
Exactly.
Oh.
Yeah, he got you there.
so global.
Hey, what are you doing? Go! I'm gonna get my back! How's that a global ride?
Well, here's the thing: we don't know, but because here's what we do know. Don't you know that it could do this, couldn't it?
Yeah, I mean.
So that would no longer be a global. But for just what we're looking at, we could call it global. It may be safest to just call it a relative, I guess. But for what what we see, it could be the global.
No, but
All
what
right.
I was saying is that because it like just goes down and it's just an arrow. It doesn't say where it ends. That's why I said it was relative.
Well, we have to think about the other side too. But they are both going down. All right. Let's take a look at this one, you guys. What is the slope at this point?
0.
No.
It does not exist. 3/4. It's not different.
It's a cusp.
Cheater.
It's not debunkable.
So this is something you have to remember from last. There's no tangent line there. You can't draw one tangent line. There's an infinite number of slopes there, so there is no slope at that point. That's remember, cusps are non-differentiable. This also happens to be a what?
Cusp.
A relative.
Relative minimum.
Okay. What's the slope here?
Global maximum.
It probably.
Oh, that's 0.
I think so, but we'll just leave relative for now.
0 and 0.
So we have 0
0 and 0.
and 0.
That's global minimum, global max.
No, it's relative.
We're going to stick with relative. And the reason we're going to stick with relative is because we don't, since they go on forever, like Nikolai pointed out, we don't know if it goes higher than that. So the best we're going to say is relative for now. All right. Guys, can we come up with a conclusion about relative mins and maxes here?
Yeah.
If a point is a relative min and a max, then the derivative
is 0.
or
The tangent line.
undefined. There you go. Okay. So if you have a relative min or a max, then either the derivative is 0 or undefined at that point. Now that's very important and very helpful to know. Remember I said that we want to get to a point where like we can find the maximum value of a function at some time. These are what we call optimization problems. But what we're going to do is we're going to find the derivative, and we're going to find out where that derivative is 0 and undefined. If we can find those, then those are our possible places where the highest point will be located. Okay? So that's our big aha from this slide, is that relative mins and maxes always are 0 or undefined derivatives.
For the cusp, what do we put? Do we put non-differentiable?
Yeah.
Can we put does not exist? Or
Yeah, I guess so. It's just a little more descriptive to say non-different. You could say not. You could say what does not exist, right? I mean, you might want to define that, right? The slope doesn't exist, right? But all right. So, what is a critical value? It's a vocabulary word. It's an x value. Now remember, we've been talking about extrema today. Those are all y values, but a critical value is the x value. So a critical value is the x value of a function such that f prime of that value is 0 or undefined. What we were just talking about. But so the biggest thing is that we're looking for the x values. That's what a critical value is, an x value. The extrema are the y values that potentially go with that x value if they exist. Okay. So why do we care about critical values? Because if f prime of that critical value is 0, or if f prime of that critical value is undefined, then f of c may be a relative extrema. Now I say maybe, right? Because it's possible that the reason it's undefined is that if there's a hole there, and if there's a hole, we know that that's not a extreme anymore, right? But if it's a cusp, and that's why the derivative doesn't exist, well, then in that case, it could be a relative min or a max. So be aware, relative extrema are critical values. So if you ever had a relative min or max, it's definitely a critical value, which means that either f prime of c equals 0 or f prime of c is undefined. It's definitely one of those two things. However, it's not necessarily true that if the derivative is 0 and undefined that it's a relative extrema. And so here's another example. Let's take this for instance. Consider this function. What's the derivative?
3x squared.
Now, I want to find out for what value of x this derivative equals 0. So what would the x value be? 0. Now let's go ahead and graph it and take a look at why that is. This is what x cubed looks like, right? Do you guys see how the tangent line would be horizontal?
Yes.
But is that a relative extrema?
No.
No. So just because the derivative is 0 or the derivative is undefined does not mean it's a relative extrema. It just means that it possibly is, and it's worth looking at to consider it. Yeah.
So would that be neither? Or
This would be a neither. Yeah. All right. We good?
I mean, I guess.
Be aware, you may lose your hair.
Haha.
All right. Identify all critical values and then determine if each critical value is a relative, min, max, or neither. So remember, a critical value excuse me. A critical value is where the slope is 0 or undefined. Okay? So tell me a critical value.
0 and 3.0.
0.
Yeah, that one.
So you guys agree that that's a critical value? Now, I guess we'll label it like this. Critical value is 0. Now, is f of 0, in other words, the y value, is that an extrema?
Looks like it.
What would you
This
call
at
it?
the end, that would be global.
Global max.
Oh, it is a global, isn't it?
Yeah.
Sure, we could do that. All right, what's another critical value?
2.0.
2?
2.0.
Sure, I'll take that. So we have another critical value at 2. Because the slope is what at 2?
0.
Horizontal, right? Is that a relative min or a max?
Neither.
It's neither.
And then 3 would be neither. And then 4 would be relative. Extreme.
All right. How about, what's another critical value?
4. 3.
3.
3 is neither.
Because there the slope is what?
0. No.
Undefined. Because what do we have there?
Oh, it's
A cusp. So when you have a cusp, it's undefined. So is f of 3 though is Neither. So that's not a max or a min.
And then 4 is relative maximum.
Okay. So is 4 a critical value?
I mean, 0.
No.
Can you really do
3.5.
Would it be undefined? Because it wouldn't be 0.
I mean, is it an endpoint or not?
That's a good point. So here's the issue. Is that this is why some people define the endpoints as relative extreme and some don't. Okay, so for a derivative to exist, technically, it's supposed to be able to have a slope from the left and the right. So if we're in that camp, is the derivative defined at that point?
No.
No. So therefore, is that a critical value? Yes.
So, wait.
Remember, if the derivative doesn't exist,
Oh, yeah.
right? So then we could call that a critical value because of that. Okay. And then that would be a what?
That would be relative.
Relative max.
Okay. But if we're going to be in the other camp of people who say that, oh, sure, we can take the derivative from one direction only,
Oh, sure.
then it's not a critical value anymore,
You betcha.
and therefore it wouldn't be a relative extreme anymore. Does that make sense?
Yeah.
So it depends on how you want to define it. Now here's your guys' only real concern. What am I going to test you on and expect from you? Well, I probably won't ask a test question quite like that, but if I do, then I'll take either answer. But the only reason why it's really important to consider them is that when you're looking for global extremas, you do want to include the endpoints, so that's why I keep mentioning it. Yeah.
So would that be the same case for 0?
Yeah. Yeah, you're right. I didn't mention at that point, did
And 1.
I? All right. Now there's other ones here.
1.
Where else do I have an?
1.
Okay. Why is 1 a critical value?
Because it's between the highest and the lowest, one of the lowest and highest points.
The slope is
Okay. So what is a critical value?
The critical value is when the derivative, you can't find the derivative from.
Is 0 or?
Undefined.
Okay. So 1. What's the slope there?
Undefined.
It is undefined. Draw your tangent line. That's a vertical line. That's an undefined slope. So you might want to draw that on there. That one's not obvious. So anytime you have a vertical horizontal line, a vertical tangent line, or a gap or a cusp, those are all critical values. So we said 1. F of 1. Now is f of 1 a relative extrema?
No.
No.
Yeah.
Negative.
All right, and then of course we also have one more critical value. What is it?
3.5.
About 3.5, right? Because there's a gap there. When there's a gap, f prime is undefined. When f prime is undefined, that's a critical value. But is that a relative extrema?
No.
No. So we have a lot of neithers up here. But we have a lot of critical values. We don't have a lot of extrema, but we do have a lot of critical values. So, in summary, where are the critical values going to be located? Endpoints. But remember, that one's depending on what textbook you're using, but we'll say endpoints. Vertical tan lines. Horizontal tan lines. Right? So, down here we had a horizontal tangent line. Here we had a vertical tangent line. Those are critical values. And also at cusps, like here, and also at gaps. Any of those are places where you have a critical value, and critical values are where the slope is undefined or 0, and any of those are potential relative extrema. No, they're going to a game or something, right? All right, so that being said, it's y'all's turn. So,
Action.
Mario,
You'll see.
can you tell me my critical values?
Negative 2.5.
What?
Negative 1.
Negative 1? No.
0.
But keep going.
0.
Let him do
Oh,
it.
I'm
There's a
so
lot of
sorry.
numbers. I'm sorry.
I didn't know you called on him. I thought you were asking.
Oh,
Good girl.
sorry. I got snappy.
and then 2.5.
Right? No.
No.
It's not 2.5.
I think that's
So-
all.
So these are it. Now, I did see a few of you guys including the endpoints, but there are no endpoints. These are arrows. So that means it just keeps going, which means those are not going to be included in our consideration. So up here, the derivative is 0, right? F prime of -2 equals 0. How about f prime of 0?
Undefined. Oh, some type.
It's 0.
Oh.
That's a horizontal tangent line. That's a 0, not vertical. And then how about f prime of 2?
0.
So they're all 0, right? There's no undefined slopes here. Yeah.
Is that point at the bottom 2 or 1.9? Because that looks like 1.9.
Yeah, it doesn't look like it's on the 2. We're gonna go with what.
Oh,
2.
okay, Jesus.
And we're gonna go with 2.
All
All right.
Try to write 2, but the
So up here we're gonna identify them. So Thomas is f of -2 in Extrema.
I can't see.
You're not helping.
Yeah, global. Wait.
It looks global, but with the arrows, the best we can say is relative. I'm abbreviating. I don't know. I would encourage you guys to do that in case you don't think you'll know what they are later. But
I'm a person.
Nick, how about f of 0?
Which Nick? Which one?
Del Rosario.
Yeah, Nick or Nick. The Asian one.
Me? Oh, okay. It's neither. Yeah.
Next step.
RMN.
So relative min.
I want an
All right. So that's it for our lesson today, guys. We're just looking at Extrema. Not too shabby, eh?
Not too crap.